Hello everyone, welcome back. In this video we are going to be talking about Newton's second law, and I'm going to be making some examples. Alright, so Newton's second law examples. Alright, so let's go back to our ice skating ring or ice skating image figure. So we had ice, a nice surface just because that is the closest to frictionless. And now let's suppose you have a box that weighs 10 kilograms. Alright, now let's say you have two people applying some type of force on it, and I'll give you the numbers right now. Again, I'm not an artist, so just bear with me. So this person is applying 10 newtons. Oops. Going that way is 10 newtons. And this person is applying 5 newtons. Both of them are perfectly horizontal to the surface, right? So this person is applying it here, this person is just applying it here on the same plane. Now, the first step, and the problem can ask you, what is the acceleration of the box? So what is the acceleration of the box? And where is it going? Now, the first thing you have to do for this type of problems is define an axis. Define if going to the right or going to the left is positive. And I'm going to say let's go to the right as positive. Alright, so now that our axis is defined, we can start working with numbers. So remember, Newton's second law tells us the sum of the forces equals to ma, right? Forces, vectors, a vectors. Now, I always like to keep the forces on the free body diagram, which is the forces on the object on the left side, and then m, which is the mass, and a on the right side, without mixing them. Some textbooks mix them together. It's like equal to, and then they list the forces equals to ma. That confuses me, so I'm just going to do it my way. I hope it helps you. If not, do whatever gives you the best results. So here, the 10 newtons are going in the opposite way, right? That we said that was positive to the right. The 10 newtons are going to the left, so it's negative. So now let's add them. What are the forces on the box? 5 newtons going to the right minus 10 newtons going to the left are going to equals ma, the direction of a. So now this will be negative 5 newtons equals to mass. What is the mass? What mass? The person? No, the force. The object, which is 10. So 10 kilograms times a. This is what we're interested in. Now we just have to divide by 10 kilograms. And now you may be thinking, wait, what happens? How is newtons equals to kilograms divided by kilograms? What's going on now? So now remember, force by definition is always ma, right? Mass is in kilograms, acceleration is meters per second squared. So a newton is equals to a kilogram times meter per second squared. So this is kilogram per meter per second squared. Kilograms cancel out. You end up having negative 0.5 meters per second squared. That would be your answer for this example, and you would say it's accelerating at 0.5 meters per second squared to the left, which, we can kind of tell by the picture. Now, another example, something very common is, what if they give it to you at an angle? Well, it's very similar, so let's work it out. So now, a box, again, and now I'm not going to draw the people out, just that was a visual. So now there's a string with a tension. A tension just means a force of 10 newtons, making an angle of 15 degrees with the ground. And then there's another string pulling on it with 5 newtons on the opposite direction. Now, what do we do here? So first, because we're talking about frictionless surfaces, so imagine ice again, we don't have to worry about friction yet for this type of problems. Alright, so we're going to do the same thing. Except that here the forces we only care about forces on the x in this case because we're moving horizontally, we're not moving vertically, we were not told so. So here, this horizontal component of this vector is going to be 10 newtons times the cosine of 15 degrees, which is 9.66 newtons. Remember, please pause this video and do this math in your calculator to make sure we're getting the right numbers. You're getting the numbers and we're on track. All right, now that you have calculated that, let's go to our math. So now we're going to say sum of the forces equals ma. Now what are the forces on this box? We only care about the x, we said, right? So let's specify that here. So then let's use the same axis that we said. So going to the right is going to be positive. So that would mean this 5 is negative, right? So now we're going to say 9.66 newtons minus 5 newtons equals to ma over the x-axis. So now this m, I didn't give it to you, so I'm just going to say it's the same 10 kilograms as the previous box. So now we just divide by 10, right? Divide by the mass, and we know that the mass is 10, so I just plugged it in. So now your acceleration over the x-axis of this box is 4.6 over 10, 6 over 10, which and this would be newtons, which remember is kilograms per meters per second squared, divided by 10 kilograms. Kilograms cancel out. So your acceleration is 0.46 meters per second squared. And it will be going to the right, while this one will be going to the left. Alright, I hope this video was helpful. Let me know what you guys would like to see. Remember, like us on Facebook and subscribe on YouTube. Have a good day.